Hello again. So for 7.5, we're going to continue using the factored form of a quadratic equation. We're going to solve now by factoring. And this is where all your factoring practice comes in very handy. So, question number 1. It simply says solve this quadratic equation by factoring. Okay, so let's just do that. You know how to factor that. If you want to get out your factoring flip book, you can. This is a simple trinomial, right? Because there's a 1 in front of the x squared. So, let me grab my pen here. We make the x, and we want to know two numbers that multiply to 28 and add to negative 11. And if you think about that, I paused and I thought about it, and I can see that negative 7 times negative 4 will give me 28, and they also add to negative 11. Okay, so simple trinomial, then I can rewrite the factors as x subtract 7 and x subtract 4. And this is an equation, so we need to carry that equals 0 down. Okay, now we ask ourselves, okay, let's just pause here and think about this. If I were to draw this, we know from the factored form of the equation that the 7 and the 4 are the zeros, right? The places where this is going to cross the x-axis. And I think it's open up, yes. So it's going to look like this, and this would be 4, and this is the 7 right there. That's the picture we've got in our heads just by looking at these two factors. Now, what we ask ourselves, this is a simple one, we can see it right away, but we need to ask ourselves, what are the values of x? Write it down. What are the values of x that make this equation true? And you're right, I can see them, because if I put a 7 in for x, this is going to be 0. 0 times this will give me 0. So if x is 7, that'll be true, or in the other factor's case, if x is 4, then the equation will be 0. We can see that, but I want to show the work because this is a pretty simple one. It's easy to see. So here I would need to write, okay, well, if I couldn't see it, this is how I would figure it out. I would write a little equation, x minus 7 equals 0, and then I would solve that equation. So I would add 7 to both sides, and then I would get x is equal to 7. And likewise, the second factor, I would do the same thing. Okay, so if I want to know what x is, or what x needs to be in order for that factor to be 0, I would set up a little equation. I will add 4 to both sides, and I will get x equals 4 and x equals 7. And you can see that's exactly what the solution was when we sketched this out. We could see that. Those are the two spots where it crosses the x-axis. And so our solution set simply is x equals 4, 7, usually in order from least to greatest. Okay, and we can check this. We could type that into Desmos and see if that's true, where the x-intercepts are. Another way we could do that is take the original equation and put a 4 in for x. Oops, 4. Okay, and once that's put in there, I would get 16 subtract 44 plus 28. And would that be 0? Yes, it is. So that factor works. And you could put the 7 in there to check as well. Okay. All right, let's move on to example number 2. Only thing different here is a little bit different to factor. So when factoring, the very first thing we look for is a greatest common factor. It looks like here, greatest common factor that I could factor out is a 3. So let's do that. If I write that, GCF equals 3 underneath, 75p squared divided by 3 is 25p squared. Subtract 192 divided by 3 is negative 64. Okay, good. Now, is this completely factored, you ask yourself? And, well, I would say no. Why not? Okay, it is a binomial, right? binomial, we know it could be a difference of squares. Is it? Okay, we'll look at the first term in that binomial. Is that a perfect square? Turns out yes. 25 and p squared are both perfect squares. And 64 is also a perfect square. And then you need to check, is this a difference? Does it have a subtract sign? Yes. Okay, so this is a difference of squares. Difference of squares we know can be factored. Remember, just bring down the 3 as square root of the first term, subtract square root of the second term, multiplied square root of the first term plus square root of the second term. Okay, and just like that, because of your knowledge of factoring, maybe you did look at your flip book, but that's factored. Okay, now what we need to do is ask ourselves, what is the value of this variable that makes the equation true? So, here, either this is equal to 0, because if that factor is 0, then 3 times 0 times whatever, it will be 0. So this factor can be 0. Set up a little equation, because unlike our first example where we could obviously see the answer would be 7 to make it 0, here it's harder to see, isn't it? So we set up first little equation from that first factor, or another option is the second factor is going to be equal to 0. 5p plus 8 equals 0. So now we just need to solve for p, and that'll tell us the value of p that would make the equation true, or make it equal to 0. So we add 8 to both sides, and then we have 5p is equal to 8, and on this side we subtract 8 from both sides. 5p equals negative 8. Then we know 5 is being multiplied by p, so we have to divide, and p equals 8/5. Or in this other case, we divide, and p is equal to negative 8/5. So our solution, p is equal to negative 8/5. We usually put the smaller one first, comma 8/5. These are the two spots where when I draw this quadratic, that's where they cross the x-axis. So we could draw a little sketch and you could check it on Desmos. That would be negative 8/5 and 8/5. It's going to open up, right, because it's a positive coefficient on the p squared. So if I would just do a rough sketch, I think it would look something like that. Go ahead and check it on Desmos, or put both of these options for p into the original equation and see if it makes it equal to 0. We're going to skip over example 3 and move to the next page. Example 4 gives you the answers, or it gives you the intercepts, and you're supposed to write the equation. Okay, so it's telling us right off the bat that x is equal to 3 and negative 2.5. So it's telling us the r and the s. If I were to draw a sketch here, I would have, I'm sorry, I said the word 3 and I wrote an x. There we go. I would have negative 2.5 and a 3 here. Okay, that would be the sketch. Now, I don't know for sure if a is positive, if it's going to open up, or if a is negative and it's going to open down. But that's what the information of the question has given me. So, our factored form is this. Y is equal to a x minus r and x minus s. Okay? And so, we can fill in what we know. We know that r is 3, x minus 3, and s, x minus s, is negative 2.5. So if you want to here, this is two negatives, we can write plus. I'll do that in the next step. The question has given us 0 other information. If we want to find a specific a, we need to know it needs one other point, so we can put it in for x and y to find a. Notice here it says write a equation. So it's telling us that there's lots of options. It's saying you can go ahead and pick your own a for this question, and but it has to have these two roots, or these two x-intercepts. So we can do that. I mean, the easiest one to pick would be 1, right? Because then It's just done. But you could pick 100 for A. You pick a -1 so that it opens down. I'm going to stick with the easiest and pick a 1. And then my final equation would simply look like this. Shazam. Not too tricky. And it didn't tell us here if it was wanting us to leave it in standard form or if this factored form is fine. If it did say standard form, of course you'd have to FOIL these factors together. Okay, now let's look down below here. Matthew solved a quadratic equation as shown. Identify and correct the error. Okay, pause it, and I'd like you to have a look. Did you look at page 404? I want you to look there and read through the solution so it makes sense to you. This is illegal in math. Of course, you won't be pulled over and ticketed, but we can't solve like this. If we wanted to solve to find the values of x, we would need to bring all the numbers to one side, have it equal to 0, and factor a square. And here, at the very bottom, is your assignment for this section. Get out your flip book and see what you can do to solve by factoring.